In this video, I plan to introduce the concept of radians and then talk about finding arc length and area of a sector in a circle. So I'm basing it off of the worksheet that you will have. But a few things we want to talk about. First of all, as we get started, when I talk about arc length, if I have a circle, pretend I can draw, the arc length would basically be like what's the distance that a little ant would have to travel if it walked along that circle? Okay, so kind of the length of this arc right here. And so what we typically do is we use a central angle, and this becomes a particular, there's theta. So if this is the angle here and this is the radius, we're trying to figure out this length. So this, you'll notice, is a fraction of the whole circumference. So it's the fraction, well, if we're writing in degrees, arc length, typically we'll say, do we say that? I think we do. Oh my goodness. Okay, it's a fraction, theta over 360 times the circumference, which is 2 pi r. Okay, so that becomes our formula for finding how long, you could think you're running on a circular track. How far did you travel? A little ant is walking on the circle. How far did it go? And then we're going to talk about radians, but let me show you what I mean by a radian. What happens here is if we have a circle, when the radius of the circle and the arc length are the same, that angle that's formed, so when this right here, this radius here, is equal to the arc length, the angle that's formed is known as 1 radian. Okay? So when r equals arc length, theta would equal 1 radian. So if we think about the whole circle, the circumference of the whole circle is equal to 2 pi r. Well, often what we like to do is we like to use a unit circle, which means that the radius is 1 unit. So if the radius is 1 unit long, then the circumference would be equal just to 2 pi. So now what we're saying here, when we think about it in terms of radians, the angle that we've gone to go the whole distance, okay, it doesn't work if you don't make the sound effect. Just kidding. Okay, the whole distance that we traveled was 2 pi when the radius is 1, and this angle that starts here and opens up and goes all the way around back to here is going to be 2 pi radians. So what we have here is that 360 degrees, that's a big degree sign, but sorry, is equivalent to 2 pi radian. Or we could even then say that 180 degrees is equivalent to pi radians. So when we start looking at this, this sort of thing, 180 degrees would go from here to here, and that is also known as pi radians. 2 pi radians, I guess they're plural. Okay, so looking back over here, what I find in this, when I want to write the equation, theta is still valid, r is still valid, but instead of saying 360 degrees, we just said that 360 degrees was equal to 2 pi. So if I look at this for radians, I have theta over 2 pi is equal to 2 pi times r. Well, notice this 2 pi cancels out with 2 pi. And so my arc length, if my theta is in terms of radians, my formula is just arc length equals theta times r. Okay? When we talk about area of a sector, an area of a sector is a little piece of pizza or pie or something like that. Okay? It's something, I probably shaded that too dark. This would be r, and this angle in here, can you see that, is theta. That's rather tricky to see. Sorry about that. If I want to find this is a fraction now of the whole area of the circle. So the area of a sector, sometimes I write it this way, area of a sector, is equal to a fraction, theta over 360 times the area is pi r squared. Okay? And I would have expected you to know these two from geometry by the time you've gotten to this course. Okay, well, so we just said that 360 degrees is 2 pi radians. So if I manipulate this, sorry, I'm going to not fit in my box very well. I notice that the pi's cancel out this time, And I will often see this written this way, that we take the 1/2 times theta r squared. And so this is the formula when theta is in terms of radians. So let's jump down and we'll do an example together. I don't know why I went to here. So when I see this one, they're telling me theta is equal to 180 degrees, and they're asking for both the arc length and the area of the sector. So arc length is going to be, since it's already in degrees, I'm going to use the degree formula. Sorry. Okay, and so that's 180 over 360 times 2 pi r. Notice this just becomes 1/2 times, well, 6 pi. That's equal to 3 pi. And my units, whatever they are they're just units. They're not squared. They're not square units. They're just regular. We have traveled this little arc. We've traveled 3 pi units. Sometimes we'll see problems that'll ask for the perimeter of a sector. And a perimeter would mean that, like, how do I enclose that whole area? So if they asked me for the perimeter, and they didn't, but if they had, we would tell them it's that 3 pi plus, notice here's one radius, here's another radius, so it would be the perimeter of that sector is 3 pi plus 6. The area is equal to, well, 180 over 360 is 1/2 pi, our r value squared. You can just tell me 9 pi over 2 or something like that. But this, the units now, whatever those units are, they're squared, because we're talking area. How much area did that have? Let's look at a slightly different one. So here's number 6. They've given it to us in radians. So I'm going to use my radian formula. And my radian formula for arc length is just arc length equals theta r. Theta r. So they tell me theta is pi over 4. They tell me r is, well, I've come from 0, 0 to 3, 0, so it's 3. So my arc length is just 3 pi over 4. And in all of these, we prefer an exact value unless they tell you otherwise. Oh, should we do a perimeter on that one again? Sure, why not? This would be 3, this would be 3, and then we just said that this piece right here is 3 pi over 4. So the perimeter becomes 3 pi over 4 plus 6. Okay, now talking area, this is in terms of radians, so I'm going to come back to the formula 1/2 theta r squared, 1/2 theta r squared, and that's 1/2 our theta we just said was pi over 4. Our r is still 3. We square this, and so our area becomes 9 pi over 8. Whatever our units are, they're now squared. So hopefully that was helpful. There's definitely some more problems to practice, including this lovely little joke down here at the bottom. So you gotta love comic strips. But basically they're saying, oh, pi over 3 radians a piece of slice, and then we're saying that the radius is 9. So this is clever, but this is the part you need for the actual problem. Good luck. Enjoy.